without further ado, I think we'll get started with Vanja, whose topic, short title is StoryFutures China.
Yeah.
So over to you, Vanja.
Yes, so I'll share my screen. I have a short presentation which I wanted to show. You can see that now, I guess.
We can now see your screen. Yeah.
Go to the full screen. So StoryFutures, quick introduction. I'm Director of Research for Brunel Design School. So I do lots of a number of different projects. And one of them is the one I'm going to talk about today. It's called StoryFutures China. It's a project which the full title is a bit long. It's a UK-China Transnational Strategic Partnership for Immersive Storytelling in Museums and Cultural Institutions. The project is funded by Arts and Humanities Research Council, and it's a 30-month project which started in February 2020 and is supposed to run until next year. We are a little bit delayed, so we may actually extend it until the end of 2022, so not finish in July, delayed because of COVID issues. The project was funded based on the proposal which we submitted to UK-China Research Industry Creative Partnerships Call that was in 2019. And the project partners are Brunel, and we are the lead, with me being the PI, Dr. Yang-Ok Choi and Dr. Lam from design being co-investigators. The partners on the project in the UK are Royal Holloway, with Professor James Bennett and Will Saunders from Royal Holloway being co-investigators, and then the industrial partner, if we can call it that way, is the National Gallery here in London, with their digital team involved in the project. In China, we work with Tongji University, specifically the College of Design and Innovation, who are the lead institution in China. And the cultural industries partner there is the Shanghai Science and Technology Museum, through their Natural History Museum branch. So the Shanghai Science and Technology Museum is quite a large entity which has a few different sub kind of organizations, including planetarium, but we work with the Natural History Museum. And then there is a company called Shanghai Foremost Group, which is a large Chinese creative industries company working on creating different museum and galleries experiences for institutions across China. The main project aim, as we kind of put it at the time, is to develop a UK-China strategic framework which is supposed to enable sustained growth of the audience for museums and cultural institutions, again, by the creative use of immersive technologies. So we started by thinking quite widely and looking into the use of VR, AR, and mixed reality as well. And the project is focusing on the strategies to grow the audience transnationally. So overall, we are interested to see how we can increase the audience for the National Gallery when it comes to the Chinese visitors, and the other way around for the museum in China. There are several work packages involved in the project. So we have a creative work package, which has the aim of creating innovative, immersive cultural experiences that enhance the audience engagement. We are then looking into the business side of things and trying to develop the understanding of the value networks and business models of the transnational cultural exchange, and immersive production that promotes growth in the creative industries in the UK and China. We are looking into user experience and trying to build a user experience model and blueprint, which translates the national experiences into the transnational and supports the audience engagement both on site and remotely. That became really important with the pandemic, as we were not able to do anything on site until recently. And then audience research, we are trying to understand basically the UK and Chinese audiences when it comes to the use of immersive technologies and the sort of cultural sector. So overall, we proposed to do something really wide when we were applying. So we said we would work with the National Gallery to see how we can create a new, interesting experience which is concerned with science in art. And then in China, with the Shanghai Science and Technology Museum, we said we would explore the viewpoint of art in science. And so that's now where we are, more or less. It's been it's a year and a half since the project started. As part of the project, we did not really commit to creating those experiences ourselves, because that's quite difficult if you want to do something at this full kind of professional level. So we ran we secured funding to hire a agency which works with us on this. And there was a competition this March and April this year to kind of select the best production agency. We had about 50 companies apply, and the one which was selected is called Arcade. They're based in London and specialize in creative work with museums and galleries across the UK mainly, but they're also very much interested to explore China as a market, and this project is supposed to facilitate this. So we are now working with them, and the experience which is being in the workings is called the Keeper of Paintings. So it's going to be an AR experience for children mainly. So we went through different kind of rounds of talks with the National Gallery to try to specify the most interesting audience segments for them. And we worked with their education department to, and after those talks, the decision was made that the most interesting audience for the gallery would be children. So our target audience are children 7 to 11 years old. And through, again, different, we are trying to apply this co-creation approach, so we had a number of rounds of creative kind of briefings with the gallery, and in the end, and also we did a number of rounds of user engagement, where and the outcome of this is an experience called the Keeper of Paintings, and that's based on the traditional role within the gallery. They have a job called the Keeper of Paintings, and that's in sort of more kind of modern terms. The job role can be described as the head curator. So the Keeper of Paintings is in charge of all the collections and making sure that they're kept in order and that they're conserved, they're kind of preserved for the future as well. And the experience is going to include a number of kind of touch points within the gallery where users are going to be able to interact with different paintings using augmented reality on their phones. At the same time, we work with Foremost in China, where they're going to create a similar experience, but based on the collection of birds within the museum of the Natural History Museum in Shanghai. And I'm not supposed to say all the details here because it's still being developed, and it's also under NDA. And we are going to launch this hopefully next year in February or March. That's the target date in the UK, and then after that in China as well. The project is a part of a much bigger picture. So Brunel also takes part in something called StoryFutures, which is a larger much larger project which was awarded to Royal Holloway. So StoryFutures China is a spin-out of that. And in addition to StoryFutures China, last year we also secured a smaller grant called StoryFutures China Plus, which is dedicated to looking at, to understanding how people like to engage with galleries and museums from home. So that's something which we are running now in parallel. And as I said before, there are two other projects. One is called StoryFutures, run by Raoul Holloway, and the other one called StoryFutures Academy, run by the National School of Television and Film. And so we are part of this kind of larger ecosystem of projects which are all kind of exploring the use of immersive technologies in different kind of cultural contexts. So that's all from me now. And if anyone has any questions, I'm happy to take them. Let me just stop sharing this. There is now, again, a follow-up funding, which we're looking at to kind of look at the longer-term engagement with China based on those projects which were already funded. So.
Thanks very much, Vanja. Does anyone have any immediate questions? Let's give people a second or two to unmute if they want to.
Okay. No? Okay.
No, it's like we had a class of students just looking at everybody's cameras turned off.
Yeah.
Okay. I mean, I suppose the you said the collaboration that there's a university, a museum, and company in China. I mean, what roles are those different organizations playing in the project, and how does
the university basically came up with the idea to do it. The gallery, the museum in China is interested to explore the use of immersive technologies to kind of grow their audiences, and the company in China is the production company, which creates experiences. So these things are quite complex, and it would be very difficult to produce something which is sort of sector leading within university by ourselves, really, right? So that's why we went with collaboration with a professional company on this. But we kind of co-create the brief and the experience concept. Mm-hmm.
Yeah, and it's. I mean, it's in the. Is the intention being that the once this is developed, I'm thinking about, I suppose, both sides of it. That what was I going to say? I mean, are you trying to develop an approach that's easily transferable, or is it actually very focused?
Yeah, I mean, the idea is to create a platform which could then be explored further in sequels, for example, and have like a longer term commercial application as well. Yeah, but I think the council was really interested to promote engagement of between the creative industries in the UK and China. There were, I think there were 7 or 8 projects funded in that round. Each one looking at different aspects of creative industries. We focus on museums and galleries. Others are looking at gaming. There is one project to do with opera and so on.
Right.
So,
okay.
But it's all about the, kind of cultural stroke economic exchange between UK and China. Mm-hmm.
Yep. Great. Anybody else want to add anything? We can save further questions for the end.
Mm-hmm.
I mean, I was slightly Vanja.
Yeah.
I was slightly reminded of a project that Abdul Sadka did a few years ago,
mm-hmm.
where he took images of artifacts in a Middle Eastern museum,
mm-hmm.
which you could then explore on the web, and they were using some of these very advanced imaging techniques.
Yeah,
meant that you could basically look at these artifacts from any direction online.
mm-hmm.
They were going to create like a digital catalog, which was then searchable of these sort of ancient artifacts,
mm-hmm.
which which kind of reminded me a little bit
of
your project, really. I mean, in some sense, but obviously with obvious differences. But
Yeah, I think what Abdul did is something which is supposed to create like a sort of online museum almost.
That's right. Yes. Yeah.
And
indeed.
I think in this case,
you're augmenting the physical experience, aren't you?
Yeah, and that's on site, but there is also something. There are actually two components. So Arcade are now also working on something which may end up on Roblox, which is a gaming platform, and there may be I'm not sure this should go online still, right? So yeah. Okay. Right. It's not really fixed yet, so I'm not supposed to talk about all the details here. Yeah, especially if that's going to be published, right? So.
And so will it sort of? I didn't quite. I mean, when you point your app at something, will it identify what it is and then tell you something about it?
So the idea is to go. You will have to point your app at different paintings, which is then going to uncover certain stories behind the paintings and point you out to certain kind of cues within the gallery where you have to then complete a specific route and preserve the, make sure that the paintings are kind of saved and kept, right?
I see.
So it's really for children who are very, very young, and it's like a playful experience. But the idea is to also educate them about the history behind the paintings and the National Gallery in general, right?
Yeah, because I have heard about using those apps where people point them at buildings and it shows you the buildings.
Yeah, so that's
100 years ago and 300 years ago, or something like that.
This is the mechanics, but this one has this experience is going to have a specific narrative, which then kind of almost. It takes you on a tour of the gallery in a playful way, right?
Yeah. Okay.
That's probably a way to summarize it.
So there's a cute little dog that you follow around or something, is there?
I mean,
there's going to be a cartoon guide, is there?
Yeah. The children are going to be placed in the role of the keeper, and they'll have certain.
Oh, I see. Right. Okay. I see. Okay. Okay. All right. Thank you. Interesting.
Right.
And one thing which I can say is that we did a number of co-creation workshops with children here and in China. So that was quite an interesting experience to kind of hear different views, different cultural views of things and so on. So
no, that does sound really interesting. And yes, I appreciate you can't tell us everything.
Partly because I'm not supposed to, and partly because it's not resolved yet. So
partly because you don't know.
One of the things which is very different in this project to, for example, the one which Geoff described, is that we approached it with a completely open-ended kind of brief, right? We just that we would explore art in science and science in art, but there was no specification of what that experience will look like.
I see. Yeah.
Okay. I think we will move on. There's a note in the chat from Tom, which is interesting. Just as a comment, Vanja. We'll move on to the next presentation. Yuri Fan from Department of Civil and Environmental Engineering is going to talk about uncertainty quantification in hydrological risk inference. 10 minutes or thereabouts, Yuri, and I shall, if you overrun, I shall warn you that you're coming to the end of your time, but over to you.
Okay, thank you, Trevor. I will share my screen. Okay, thank you very much. And here I want to introduce one of my research work with collaboration with our colleagues from Brunel University. So the title of our research is Factorial Multimodal based Cochlear methods for uncertainty quantification and partitioning of hydrological risk inference. So in general, we already know that many extreme hydrological events such as floods and heavy rainfalls already led to severe losses, especially in recent years. And also these kind of extreme events such as a flood usually have multiple features. So if we see this from this figure, so this is a flood event. So from here we can see this kind of event can be characterized by its peak flow at this point, and also the flood volume for the whole flood event. So this means that we need to analyze the flood risk or any hydrological risk within a multivariate context. So in general, and also in the last decade, the method of Cochlear has been widely used to analyze the hydrological risk analysis for multivariate flood variables. However, there are some uncertainties exist in both univariate and multivariate hydrological risk analysis. So these uncertainties may come from different sources, such as data availability. So for different hydrological stations, we may have 30 years, 50 years, or even 100-year records. Another one is model selection. So we may have different models to quantify the historical probability features and then to get the flood risk and also the parameters in these models, in these marginal and Cochlear models. So due to these uncertainties, so this will lead to imprecise risk inferences, such as for the same flood event, if we use different model, we may have different return periods. Similarly, for the same return period, if we use different models or consider different parameter sets, we may have different flood magnitude. So our research is to address how these uncertainties will influence the hydrological risk analysis. So some challenges exist in these issues. The first one is quantify parameters or quantify parameter uncertainties in hydrological risk models, and also characterize contributions from different uncertain factors to the risk analysis. So to address these challenges, here we propose a factorial multimodal Bayesian Cochlear method. So in this method, we use MC to quantify parameter uncertainties for the Cochlear model with different marginal and dependent structures. And then we use multi-level factorial analysis to characterize the dominant contributors to the risk references. So here is the framework of the methodology. So if we consider different variables, then we use different marginal distributions, and then use Cochlear to connect these variables. And finally, and then we use MC Markov chain and color methods, quantify the probability of these parameters in both marginal distribution and the Cochlear model. And then we use factorial design to characterize the dominant contributors. These contributors include the marginal distribution, the Cochlear model, and also the parameters to the results, to the final risk results. So firstly, I just give you a brief introduction about the Cochlear model, okay? So firstly, if we consider some hydrological hazards with correlated attributes, such as the peak flow and the volume for the flood, then the joint probability of the peak and volume can be expressed by this distribution. Here F is a joint probability distribution for multiple variables, and C is a Cochlear function, and Fi, Fy from Ft means the marginal distribution for the individual variable. So based on this joint distribution, we can get the joint return period and also the failure probability. So in general, we have 3 joint return periods and also failure probabilities in OR and Kindle. So this is their expressions. So, and how to, what's the meaning of this joint return periods? So here I use a figure to describe this return periods in OR and Kindle. So this is OR. This gray, so this gray region means that this means that the events lead to the failure of the extreme events happen in this gray area. This means that each attributes exceed any of its attributes exceed a threshold, and the Kindle means that both variable exceed their threshold, and the Kindle means that the joint probability here is the joint probability of the variable 1 and variable 2 has a specific probability, current probability, such as this. If this is 100-year return period, this means that their joint probability is 0.99. Okay, so this is a different meaning of a return period in OR and Kindle. So if we just recall the distribution of the joint probability of for multi-variables. So here there are different uncertainties exist in this Cochlear model. So the first one is the different Cochlear model structures. So as shown in this table, here this is Clayton, this is Gumbel, this is Frank. So there are different structure for the Cochlear models, and also for the modular distribution, here F1 to FD. So such as the log normal, the Pearson type 3, this one, and also the GV model. Okay, this is the second uncertain source. The third one is the parameters. So the gamma I in the modular distribution and also the seed in the Cochlear model. So next step is we want to know from these uncertain factors which one will contribute most to the results. So to do that, we will use, which here we just introduce the multi-level factorial analysis. So this is a general model. So this is a variability of the risk prediction. So the total variability can be decomposed by these components. And based on these components, we can specify the distributions. So this is the contributions. So this is a contribution from the marginal distributions. So this is from marginal 1, from marginal B, and also the contribution from the dependent structure. So here the dependent structure means the Cochlear model. And then the contribution from the parameter uncertainty expressed by eta E. So here, this one. So this is the general methodology. And here we just applied this method to the River Basin, to the flood event at the Zhangjiaoshan station and the Shenyang station in the Wei River Basin. So here is the marginals. So here in our study, we choose 3 marginal distributions. So P3, DV, and log normal. And also we consider 3 popular functions, the Frank, Gumbel, and Clayton. And for each model, in each zone, we use the MCMC to quantify the parameters in the marginal 1, marginal 2, and the Cochlear model. And then we use the multi-level factorial analysis to reveal the dominant contributors. Okay, so here is the results. So so if we can see from this figure, for one specific parameter, may have different distributions in different models. So this, we think it have 2 possible reasons. The first one is that because for each model we use MCMC to get the parameters. So for different runs may lead different results. So the second one is that because if we choose different models, this means that the parameters in the marginal and the Cochlear model may have some correlation. So if we change one model, this means that we also change the parameter. Due to their correlation, it will lead to some different results for other parameters. And also, so here, and also due to these uncertainties, it will lead to uncertainty, due to the uncertainties in the marginal, the Cochlear model, and also the parameters. They will also lead to uncertainty in the multivariate risk inference. So as shown in this figure, so this is the joint return period in N. So here the curve, the red curve means the average value from all the Cochlear models with different marginal and dependent structures as well as parameters. And here, this curve, this colored region means the return period obtained from different Cochlears with different marginal distribution. So we can see that, for different marginal and the Cochlear model, and also consider the parameters, it will lead to some, very imprecise results. So this is the uncertainty in the results. So next step, we just explore which parameter will contribute most to this uncertainty results. So this is a ranking for the contribution from different models, from different factors. So here we can see the Cochlear function will dominate the predictive uncertainties in the failure probability in N, and also the second one is parameters. So in comparison, the marginals. So here A, B means the marginal distribution. So the structure of marginal distribution as well as the interaxes are not significantly impact the results. So for the joint probability in OR, we can see the parameters, the parameter uncertainties may be the first significant factor. And in comparison, the marginal tend to have much more effects than the effects from the Cochlear structure A and B. But the Cochlear function for the joint return period in OR may have very little effect. And for the joint return period in Kindle, so the parameter uncertainty is not is not negligible. So they are very significant. And also the Cochlear model, And then the interaction between the marginal B and C means the Cochlear model. Okay, so this is the findings from our study. So in closing, so in our study, so a factorial multimodal based Cochlear method have been proposed to quantify uncertainties and also partition their effects in multivariate hydrological risk inference. So in our results indicates that the Cochlear structure tend to dominate the failure probabilities in N and Kindle, followed by the parameter uncertainties. And also the parameter uncertainty and the marginal structure would be significantly affect the failure probability in OR. So our study has been published on general hydrology. If any people want to see more details, you can refer to this article. So this is my presentation. Thank you.
Thanks very much, Yuri. Can you just unshare your screen for a moment?
Okay.
Brilliant. Thank you. Again, does anyone have any immediate questions? I suppose just quickly, Yuri, whenever I hear people talk about those sorts of analyses, I always think about the practical application from the engineer doing an engineering design. who is asked to do a design based on a 50-year event or a 100-year event. How do you feed in these new results into design approaches?
Yeah, this is a good question. So we also think about how to apply this kind of method to practical design. So our method here, firstly, our method can provide some pathway to improve the results, to improve the result prediction. So, for example, if we want to consider joint re-temperature and if we want to have more better results, we may firstly if we want to adjust, we may choose a better Cochlear model. So this is here just give you a direction how to improve the X-ray more efficiently. So another way we just consider is that, so here we just consider different model and also consider parameters. So in future, we want to combine these results together to give a predictive interval for specific results. So this means that if we want to get a design, we may just working up, the predictive interval between 5% to 95, between 90% predictive interval. So here give the designer the flexibility. You tell him if you have a design, how is the probability for this design. So this is two. I think our understanding, this may be the two way for predictive for practical applications.
Yeah, no, I understand that. But it may take some time before it feeds through into design manuals and so on, but it will come. Excellent. Anybody else quickly? No, we might just move on because
Can I quickly?
Oh, please do. Sorry. Yes.
Yeah. Thank you for a good presentation. I also work with mathematical modeling of engineering application, but it's slightly different. My question is, probably you might be touched in this last comment. You have model and you have some data, and have you ever verified your model prediction works?
Okay, so in fact, this is a statistical model. So before we do application, every model has passed the statistical test. So we have statistical test to verify that our model is correct.
So okay, so it works with the real scenario. The date you have some data, you test the data with the model, and with the statistical model, it works. So that means it can be used in future to predict things. Is that right?
Yes. So currently the data are the real observations, and we use statistical model to fit their distribution from data, and they use statistical test to verify that our fitted model is right.
Okay.
So this is our way to verify our model.
All right. Okay. All right. Thank you.
Yeah. And I think that it's fair to say that testing these models is actually quite challenging because you're dealing with the extremes of distributions. And,
Yes.
That's what
I was wondering. Yeah.
It's always difficult to get good fits to the extremes, and one extra data point sometimes makes quite a difference to your results. So yeah, Yuri's approach is helping us refine some of that, I think. Great. Let's move on. Tao is going, also from civil and environmental engineering, is going to also talk about hazards. This time it's earthquake-induced landslides in southwest China. So as with the others, Tao, around about 10 minutes. Over to you.
Okay, thank you, Trevor. So let me share my screen. Okay, so can you see my screen?
Yes.
Yes, perfect. So good afternoon, everybody. My name is Chao Zhang. I'm from the Department of Civil and Environmental Engineering. Today is my great pleasure to get the chance to present my research. So I joined Brunel in 2018, and before that, I worked in China for 4 years. So during my career in China and also my current research, I have the chance to collaborate with some Chinese researchers. So today I'm going to present part of my research on landslide hazard. So the title is Assessing the Risks of Earthquake-Induced Landslides in Southwest China. So as background information, landslide is defined as the movement of a mass of rock, debris, or earth materials down slope under the direct influence of gravity. So basically, when the forces acting on the slope, like gravity, exceeds the strength of the material, the landslide will occur. So there are different kinds of causes. For instance, rainfall, slow melt, change of water level, stream erosion, earthquake, volcanic activity, and human activities. So among others, the earthquake has been identified as the most significant factor trigger the landslide. So let me give you some rough idea. So here's a map showing the global distribution of landslide. So you can see the landslides distribute mainly along the major large mountains and also at the boundary between the continents. For instance, the Rocky Mountain in North America and South America, and the mountains in the Central, East, and South Asia. So according to the statistics between the 1998 to 2017, landslides has affected an estimated of 4.8 million people and caused more than 18,000 deaths. And the climate change and the rising temperature are expected to increase the landslide frequency as well. Here I'm showing you this map of the global hazard map. So you can see the distribution of landslides and the distribution of earthquake. They are highly correlated. So which means that earthquake is the main factor triggering the landslides. In particular, in the East Asia and China, here you can see the landslide hazard is really high. Okay, so let me give you a detailed look, overview of the Chinese landslide distribution. So here is the map, the topographic map, showing you the landslides in China and also the elevation of different lands in China. So you can see on this map, landslides distributes mainly in the central and the southwest part of China. In each year, there are more than 30,000 landslide events in China and 800 people dead or missing. The economic cost can be more than 4 billion RMB. So on this map, we can roughly have 3 regions. You can see the dashed line here, the east, middle, and west. So you can see in the east, the elevation of the land is very low, normally below 100 meters. So the landslide hazard in this area is quite low. I mean, there are some landslides, but not very severe. And the middle region of the country, you can see there are lots of landslides because in this area, there are lots of middle to high mountains. And if we move to the west, the lots of high mountains, the plantains, particularly the Tibet plantain. So in these high lands, there is quite few landslides. So the landslide concentrates mainly at the boundary between the regions, particularly here, between the middle and west. So this area, the Normanshan fault zone, just close to the Tibet region. So you can see here, landslide concentration is very high. And the 2008 earthquake occurred in this region, and this single earthquake has triggered more than 15,000 landslide events and roughly around 20,000 people deaths. So here are some photos obtained from social media showing you the destruction of the landslides during and after the earthquake. So you can see the destruction power of landslides is quite significant. So it's very important for us to do some research on the landslide risks in the southwest China. Our focus of the research is on the landslide hazard and the risk. This is a very broad topic for research. So we have 4 different subtopics. Sorry, I think I need to go back. So here, so for this, we have 4 subtopics. The types of unstable debris and quick state of slope failure, dynamics of landslide, and the impact landslide on the infrastructures. So for these topics, we have a set of different research methods. The first one is the field investigation, which has been used to identify the types of unstable debris and the impact of infrastructures. So for the field investigation, during my career in China, I have joined several different field investigations. For instance, the 2017 investigation, we went to the Wenchuan area to study the earthquake-induced landslide there. The top right one shows you the field trip in the Dongchuan region. So Dongchuan region is at the boundary between the Sichuan province and also the Yunnan province. So in that area, there are lots of earthquakes in each year, and the vegetation on the surface of the slope is very low. So each year after rainfall, there are lots of landslides there. And the last one shows you the field trip to the Tibet region, and that's the visit to a historical landslide in Yigong Linqi region. So these field trips have been supported by the National Science Foundation of China and some open research fund from the Chinese Academy of Sciences. The second and third research methods are the land tests and the physical modeling, which has been used to assess the quick state of slope failure and the dynamics of landslides. In the lab, we have built small-scale landslide flume to test the dynamics of the debris materials, and also we can test the strength of a single rock block. We also use the 3D laser scanner to get the surface morphology of the particles. So we start from the micro scale to study the single particle behavior, and then we try to reproduce the dynamics of the collective behavior of the landslide. So these research have been supported by the Royal Society, the International Exchange Scheme, and also the Open Research Fund of the Chinese Academy of Sciences. So based on the previous 3 types of research methods, we have proposed some numerical models for numerical simulation. We have used different type of research methods like DEM, FEM, SPH, and CFD. So the numerical simulation requires the input from the previous 3 types of research. For numerical simulation, our recent work focuses mostly on the quantification of soil property. So you can see the top corner, top left corner, shows you 2 photos of the soil at different scales. The first one roughly 5 meters, but the second one shows you the scale of 70 micrometers. So you can see from different scales, the soil is never homogeneous. So soil is like type of inhomogeneous material. So our simulation tried to reproduce this inhomogeneous property of soil using the random field theory and also the discrete element method. You can see this animation shows you the progressive failure of the slope under the seismic loading. So this research is also supported by the EPSRC and the Open Research Fund from Wuhan University. So the numerical simulation has been further used to evaluate the quick state of the slope and dynamics of the landslide. And finally, we are hoping to propose the whole process modeling of the slope failure, landslide, dynamics, and deforestation. So for this research, this is ongoing research funded by EPSRC. So here is the schematical view of the slope failure. And from the right to the left, you can see we start from the macro scale for the real slope. For the macro scale slope, during the failure, you can see some very large fractures and also the slope fragments. And then in the middle, we have the mesoscale model. So if we just sample some rock or soil from the field, we can test the rock or soil property in the lab. So this is meso scale. And if we move to the deeper, to the micro scale, we can see the fluid flow within the passages between the particles. That's the homogeneous fluid solid mixture in the fragmented zones. And we also have this large scale Flume test supported by the Chinese Academy of Sciences. So our partner in China, they have constructed this world's largest landslide testing Flume in Dongchuan area. So you can see they selected this slope, lateral slope, and then they place this large Flume just on the slope. So this Flume has the length of 172 meters, the width of 4 meters, depth of 4 meters. It's huge. And in each round of the test, we can use roughly up to 500 cubic meters of soil or rock. So this large-scale test platform can largely reproduce the real behavior of the natural landslides. And in this test, we can reproduce the multi-scale, multi-phase, and multi-physics of the landslide hazard. And we can also observe clearly the slope fragmentation, material inhomogeneity, and uncertainties will also be studied in this research topic. So finally, we can also implement the model in the high-performance computing to study the landslide hazards and risks, and also to evaluate the impact of landslides on the major infrastructures. So lastly, I want to share my experience of working with Chinese researchers. For collaboration, the research grants can be a key. So here I just summarize some of the possible research grants can be used for the research collaboration with Chinese researchers. Maybe if you know more, just share your experience, because it's just based on my limited knowledge on this. So the first type of grant can be the Royal Society. So there are two types of grants: international exchange scheme and also the international collaboration. For EPSRC, you can apply this overseas travel grant. For NERC, we have this global partnership Sitcoin fund. And the last one is the State Key Laboratory Open Grant in Chinese universities and research institutes for the research collaborations. So the last type of research grant can be very easy to be obtained if you have the collaboration with the Chinese researchers. Okay, so that's all for my presentation today. If you have any questions, just ask. Thank you.
Thanks very much, Tao. Again, if anybody have any immediate questions. Wenming.
Yes, thank you. Very interesting presentation, which is totally out of my knowledge zones. I think you do lots of studies for the very basically in theory or modeling things. But in the case of in the real environment, people just live by the hill or down the hill. And because the surface of the earth are very limited, our population are keep increasing. So you can't move the people outside or far away from the slopes. What would be the solution if we're looking forward? How we can think about these things, and where we can to reserve more space for people to live. Thank you.
Sure. So, yes, in the very remote areas, the people living on the hills, in the mountains, this is quite normal. And according to the requirement of the research grant, for instance, the EPSRC, we need to address this national impact or social impact. For instance, we need to involve the public in our research. For instance, for our research, we can generate the guidelines to mitigate the landslide hazards, and also like mitigation measures. So try to give some like easily understand the knowledge to tell people which kind of slope is unstable, to try to avoid any damage or casualties, just like this.
Okay, thank you. Thank you.
Yeah, no, it's a good question, Wenming. Any other questions? I like that experimental facility, Tao. That looks really exciting.
Yeah, the field test model and field test platform is, I think they are just still under construction, so they will complete, should be next year. So we try to get involved in the early stages, so that will make our Brunel researchers can get involved in this kind of collaboration work. So we try to use this world's largest platform to do some tests. It can be useful and meaningful to get some data.
Yeah, no, it will be really interesting to see how it works. It's such big scale. You can do some interesting things there, I think. Yeah, well, that's something to go and look at on a future visit to China. We better move on. We've allowed things to drift slightly because the talk's been interesting, which is good. The last talk is from me, so I shall now share my screen and share the correct screen. Let's see. Okay. Participants, can I see it? Oh, is that right? Can you now see the presentation? Okay.
Yes, we can.
Yes, good.
Yes.
Good. So following the same theme a little bit in terms of the last two, in terms of talking about environmental research. The topic here, though, is slightly different, and it's getting slightly away from my own sort of comfort zone. So this was work done as part of a large consortium, as you can see, led by Fabrice Renaud at University of Glasgow, with colleagues from Nankai, Loughborough, IGS in Japan, and I was involved in some of the flood-related work. And this is a project that has actually just come to an end. The presentation here is very timely because actually Fabrice has just given this presentation to a NERC panel this morning. So I'm using his slides largely, so acknowledgement to him for putting this together. The one bit of context though, for those of us who know about transnational education and know about Brunel's TNE operations in China, this grant actually came from a TNE partnership. So Fabrice, Brian Barrett and myself were all involved in teaching at Glasgow's TNE master's program at Nankai University with Sui-Ling Huang, who's one of the other co-investigators. And this grant came directly out of a research symposium that was organised as part of that TNE partnership. And then the opportunity came up to apply for funding. So we did, and we won the funding. So it's a nice example of how TNE can lead to research developments, rather like what Tao was just saying about the sort of history of how you get funding for these things. It's always interesting to know how people get their research supported. The project was part of a UKRI programme on towards a sustainable Earth. So it was focused around the Sustainable Development Goals. And obviously the SDGs are quite wide ranging. And when you start to think about it, there are places where the SDGs reinforce each other. There are other places where they maybe go, there were some trade-offs and differences between them. So for example, to produce the food required to reduce hunger, you might actually be leading to soil degradation and causing pollution on land or in water. And so there are trade-offs implicit within the SDGs. So we, based upon work that some of our collaborators, especially the group in Japan, had done previously, looking at trade-offs between the SDGs and targets, was to say, how do those trade-offs work? And do they create inequalities that we can perhaps manage, and we can perhaps make some policy recommendations as to how you avoid or minimize these, based upon the overarching aim there, which is about scientifically grounded policy relevant information, so that you're not just doing this in abstract, we're actually using as much data as possible. And as I'll show you in a moment, some modeling of land use changes, flood risk, and so on. So that's the background. We worked in North China, this river basin called the Ruanghe River Basin, which flows out into the sea here, and on the map of China, so Beijing's roughly in here rather. City of Tianjin is on the coast, so this is just north of Beijing. And in British terms, this is quite a large river basin. The area of this is about half the area of England, so it's quite large scale by British standards, although compared to the large rivers in China, it's not so large. And it's a river catchment that is ranges from hills rather than mountains, and grassland in Mongolia, up at the upstream end, all of the way out to where it enters the sea near the city of Tianjin, down here. Why is it an important area? Well, occasionally you see this sort of story in the news. What are referred to as sandstorms, dust storms, often affect Beijing, Tianjin, other population centers. And a lot of the soil that is in the air here that's causing these dust storms comes from within this basin, comes from areas that have been eroded, where the vegetation is degraded. And when you get, it's a very dry part of the world, very cold in winter, very hot and dry in summer. So the soil is quite loose. When you get high winds, you can get these dust storms in Beijing. So there's a real importance actually to this part of China, and a lot of work has gone into designing land management strategies to try to reduce that hazard.
Sorry to interrupt you. I can only see the first slide. Is that things wrong with my computer? Which slide are you?
So just to give you an indication as to what this area looks like a little bit, I actually, when the rest of the team visited this, it was just after I'd come to work at Brunel. I wasn't able to go with them, but you get a sense of the upper part of the catchment with grasslands, and quite a lot of forests has been planted to try to reduce the sandstorm problem. There is agriculture in the basin. There are some big reservoirs, and ultimately it flows into the sea, as we mentioned earlier. So quite a varied landscape here. And the way in which we approached the project was to start by thinking about, well, what are the projected land use and climate trends in this area over the next 50 years in particular, and all the way through to 2100, that will allow us to model what might happen to the landscape. So the modeling was done based upon a range of scenarios. There was a trend scenario, which is just continuing modern or recent socioeconomic development trends continuing. There was an expansion scenario where actually there is growth in the global economy and urbanization, but actually growth in China in particular. A sustainability pathway, which is defined by UN around ensuring sustainability of resource use, and there are some Chinese laws and planning guidance that help define that scenario, and a conservation scenario, which is where positive efforts are made to reduce soil erosion, to improve water use within the catchment. And the details of this, I'm just going to skip over, but just to give you some sense that we were modeling different scenarios based upon different socioeconomic development pathways. We then used those to make predictions about what land use changes might occur as a result of those different scenarios. For example, under the conservation scenario, there'll be a lot more forest planted to try to reduce soil erosion. The expansion scenario, though, would require more land for agricultural food production and therefore less forest. And so there are differences in these scenarios. All of them require some agricultural intensification because of the demand for feeding people, but differences in the forest areas, differences in water scarcity as a result. So some of the team, led by some of the Glasgow colleagues, did this land use modelling, and they were then able to use this model to predict ecosystem services and disservices arising from those land use changes. So and ecosystem services are the positive things that ecosystems give to us in terms of absorbing carbon from the atmosphere, for example, providing water, biodiversity, providing fertile soil, and then disservices are pollution, concentration of pollutants, for example, areas that are flooded, etc. Included, of course, within this, you'll see if you can read quite small on the screen that, for example, cultural services are included because in terms of recreational spaces and other uses of the land for non-food or resource purposes. So there's quite a lot of data goes into this, and then we use that data to do other forms of modelling, and this is part I was involved in, where we did some flood risk modelling, and we looked at how many people were going to be at risk under different scenarios, what might happen if reservoirs were enlarged, or indeed if a reservoir stopped being used, because there are negative consequences of impounding the water in reservoirs. And we again, for each of the scenarios and over different timescales, came up with predictions about the amount of lands that would be flooded under a flood of a given size. And we can turn those into maps. And so we can actually show people these and say, if under different scenarios, this is the area that we predict will be flooded with a certain degree of regularity. So there's a lot of data, a lot of modelling, and quite a lot of science behind the project. And that was done by the different teams at the UK universities. So ourselves, Brunel, Loughborough were involved in Glasgow. And then this was put together by the team in Japan, who have developed a really interesting methodology and an online tool for looking at how the Sustainable Development Goals link together. And I'm not going to explain this in any detail, but it's an online tool that tries to link all of the SDGs and tries to put data that help you define those SDGs against each of them, and then look at the trade-offs and complementarities. And if you're interested, the basic tool is available online. And the result is, I suppose, is complicated. Now, the modelling framework they use is this one that has drivers, pressures, impacts, responses. Sometimes you see it with state rather than pressures in here, but and then you won't be able to read all of the words on here, but these are different features. For example, the drivers include things like urbanisation and climate change. The responses include things like hydropower generation, water supply, impacts on economic growth and development, pressures on pollution, for example. And all of these lines are showing where interactions have been identified between these different factors. And then there are some very small numbers against these, which are the SDGs. The SDG numbers is the first number in each of these pairs of brackets. So SDG 11, SDGs 2 and 14 for fisheries and aquaculture, for example.
Trevor, sorry to interrupt. Would it be possible to move the slides along, please? We're still on the holding slide.
Oh, not on my screen, you're not? Ah, that's interesting. What's it done? Hang on.
It's frozen, has it?
It's frozen up. Has it moved now?
Yes.
Okay. It's something. Okay. Sorry about that. Okay. So you've missed all these nice, pretty pictures. Apologies for that. I can let people have a look at it. So the bit where I was talking about before, with the dust storms and so on, those are the images that you will have missed. I better get back so we don't run out of time. I will just skip through quickly. And hopefully what I've said has made some sense about data and the approach being based on putting a lot of data from different sources together. This is the flood modelling that I was mentioning. And then this was where I got to just talking about the methodology behind looking at the interlinkages between the SDGs. And the result is this very complicated sort of matrix of drivers, pressures, impacts, responses. And this is what I was just saying, that the different SDGs, which are the tiny numbers here, how those SDGs can sometimes reinforce, sometimes though they are at tension with each other, and there are trade-offs and conflicts between them. And what the analysis tool does is it takes a lot of data on population, on land use, on roads, on economic development, on power generation, on pollution, and it puts those data together and then, as far as possible, automates the examination of these linkages between the different SDGs. And the sort of output you get from that, and this is a couple of examples for different counties, you see all of those interactions below, and then for each area it pulls out the, if you like, the most important ones. And we've chosen here to highlight climate change because climate change is obviously a key issue. And then the ones that are highlighted in red, blue and green here are the most important of those linkages that we identify for climate change. And you can compare this area a long way up into the catchment with this one here, and we could have looked at one down towards the sea, for example. And you can say, well, are they the same? Are they different? And there's a lot of similarities, but there are some important differences because of different land uses, different population densities, and so on. So that's how it works. So it's a combination of a lot of data, overlaying that data, doing sort of statistical correlations and cross correlations between the data, and then summarizing that in these sort of graphical outputs. Now, from all of that work that, as I say, the Japanese team have done, the particular data for this site is going to be released next month. Some recommendations come out of that, and won't go through these in any detail, but it's a bit like in the question that Tao was answering at the end of his presentation. How do you take the science and how do you feed that through into what people should do? And this is recommendations for policymakers, but also recommendations for people living in this area. So to give you an example of the sort of recommendations that have come out of the project, recommendations around afforestation and how that might actually be implemented. Important recommendations around water, because water scarcity is a very big issue in this area, and with climate change, water scarcity is only going to increase. So there needs to be sustainable water management policies. There also needs to be some interesting work in China with trans-provincial water transfers. A lot of Beijing's water doesn't rain anywhere near Beijing. It comes down as rain in the mountains in South China and is piped to Beijing. And so there needs to be thoughts about what are called here eco-compensation schemes to try to protect water quality. And then real need to think about urban development and the trade-offs with flood risk. And again, linking back to Tao's presentation, he was showing some of the impacts of landsliding on development. Here we're thinking about the impacts of flooding on developments. There's a real need to try to integrate policies, which isn't an unusual message. You get that in countries throughout the world. Where's this project going, just finally? Well, it's going in a policy direction in that we've written a policy brief, which has been translated into Chinese and is open access. It has going into work carried out by a range of different stakeholders. Some of them are, again, if you can read this, research institutes, government agencies in China, national agencies and local, and also UN bodies. And it's also going into publications, and we've got a series of papers coming out in the Journal of Sustainability Science in the next little while. I shall leave it there, and apologies for getting the screen sharing wrong at the outset. I'm quite happy to share these slides if anybody wants to look at them at more leisure afterwards. So I shall stop the share. And if anybody has any questions, we've got 3 or 4 minutes left before we should wrap up. Over to you. Total silence, that's good. Okay, that's all right. It's fine. Are there any residual questions for any of the speakers while we still have everybody here?
Sorry, Trevor. Probably I have one question about your project. So
yeah,
for this catchment, which kind of model you are used for, like for the simulation work?
Yeah. So the flood simulation was done using a model that's called Hydrological, which was developed by the research team that's now based at Loughborough, was previously at Newcastle University, led by Chuihua Liang, and it was Chuihua and Shilin Xia from Loughborough who developed this model as part of Shilin's PhD, and it's not unlike other hydrological models. It's a catchment scale hydrological model based upon fairly standard hydrological routing equations and solved in a finite element framework. I forget the resolution we used for this model. I think it was a 10-meter spatial grid that we used over the whole catchment. So model runs were taking on an HPC platform. They were taking 1 to 2 days, I think, to run each model.
Okay. Thank you.
Yeah, can I have a question?
Yeah.
Yes, I think the flooding could be an issue everywhere, but there's also, particularly in China, there has already built up lots of the reservoirs. They have different way to manage those reservoirs. How will that affect your modeling? I mean, to considering the real situation happening.
Yeah. So in the catchment we looked at, there's one big reservoir and there's another one being planned, and they have quite a significant impact on downstream flooding. I mean, they're there for 3 reasons. One is to provide water supply for the cities, one is for flood control, and one is for hydropower generation. And the modelling shows that they are quite effective in reducing flooding. If we take the reservoir out of the model and predict what the flood extent would be, we can see the difference and we can see the effectiveness. So the effect of the reservoirs in many ways is very quantifiable, and you could say it's all very positive. You then have to look though at the trade-offs, and that's what part of the project was about, because the reservoir, if you have the reservoir, it means you have less water going downstream, which changes the ecology downstream. It means there's less water available for agriculture downstream. The reservoirs are big enough that they affect the local climate around the reservoir, and so they change the environment. So we have to think about those consequences as well as the positive ones. And the challenge is knowing how you balance those different things, how you decide which is the most important factor, which factors you'll accept being a negative because you've got the net positives. And certainly in terms of flood control, the reservoirs here are very effective. Because there's been soil erosion, they have started to fill in with sediment over time, though, and that's another cost, actually. If you want to maintain the reservoirs, you have to go and remove that sediment at some stage. So there's a range of trade-offs in how the reservoirs operate, and I think that's a real challenge for environmental planning going forward, is how we quantify those trade-offs.
Yes, can I just follow a little bit? So I saw some of the video program on the YouTube. tubers. They say the reservoir, they may have different priorities. Some may just fully for manage the floods. Some may still have some side functions for economy. So they may use that water to develop the economies. So what's your comment? Say is that reservoir just should be purely for the environment protection, for protect the flooding, or can be both for economic development?
Yeah, it can be for both. I mean, normally water supply and flood protection both go together, so you can have both of those at the same time. There's been quite a lot of work done, especially in the US in the last 20 years or so, looking at how you manage reservoirs to reduce the negative effects. So maybe you don't keep all of the water in the reservoirs, you release some of it downstream to try to maintain the ecology downstream. And you might do that. You might release some small floods downstream because those small floods have benefits to against the ecology and to how the rivers downstream function. So there are different ways of managing reservoirs, which are becoming more sophisticated, I think, as we understand better what all the potential benefits and costs are. In China, historically, there have been very many small reservoirs. And the cumulative effect in a big river like the Yangtze of those small reservoirs and small dams is really quite significant. And so there's a lot of analysis being done in China at the moment not to look at the impact of individual reservoirs and dams, but to look at the cumulative overall effect. And I think for longer term environmental management, that's something we need to understand is what's better. Is one large reservoir better, or are three small ones better? And how do you manage those different sort of configurations?
Thank you very much.
Yeah, really interesting questions. We've managed to use the full hour and a half, and we really better let people go now because I know people will have other things they need to go on to. Thank you very much to the speakers. Really interesting range of topics